Hi, Christopher Hughes for BoatTest.com. Today we're going behind the scenes at the Boston Boat Works, the manufacturer of MJM Yachts. These yachts are manufactured utilizing a unique and technologically sophisticated process and materials. Let's see how it's done. The process for creating the hull and the deck are exactly the same, with a gel coat being applied to the mold and then a vinyl ester tie coat being applied on top of that. From this point on is where the construction of an MJM yacht differs from traditional methods and materials. At this stage, if we were building a hull, it would receive a layer of Kevlar E-glass hybrid for impact strength. But let's take a look at the deck being constructed. On top of the tie coat, they apply an epoxy laminate of multiple layers of unidirectional fiberglass specifically oriented with the loads in the structure of the boat. This sample of triaxial glass shows the longitudinal fibers that run the full length of the vessel, and on the other side, run at plus and minus 45 degrees to take crosswise loads. MJMs are built with epoxy resin because of its exceptional toughness, which allows it to absorb strains up to 2 to 3 times what normal polyester resin can withstand. It is on this layer that the unique structure of the deck and hull are formed. They first coat engineered foam cores with epoxy and begin to apply them in layers within the mold. Here you can see there are different colors of foam core, and that is because each is engineered to carry different loads. The light green is a 5-pound core, and the dark Penske board is a 25-pound core. This core material is computer cut and comes in a large box as a model-specific kit, as you can see here. Each of these cores has a different density and a number which identifies its specific location within the hull or the deck mold. The team uses a map that shows exactly where each numbered core part is to be placed. Here you can see how complex the assembly process actually is, with each core piece being coated, then placed. After the foam cores are in place, they add additional layers of biaxial fiberglass fabric, as you can see here, going over a piece of the Penske core at the bow on the deck. Note that the deck is assembled upside down in the mold. In locations where hardware will be mounted, special high-density core blocks are used in addition to aluminum backing plates. Before any of the biaxial glass fabric is applied, it is first impregnated with the epoxy resin. Here you can see the process, which utilizes a specialized machine. The fabric is fed through a bath of epoxy, then between rollers which control the ratio of resin. It is important to note that the ratio of resin to the glass fabric by weight is exactly 60 to 40, 60% glass weight to 40% resin. This is important because the strength comes from the glass. Here you can see how the resin impregnated bi-glass is then applied to the foam core structure, with the main strands running bow to stern. This completes the main structural process and leaves us with the outer gel coat, a tie coat, an epoxy laminate layer, and the engineered foam core, all enclosed in the last layer of bi-glass. This process and these materials enable each MJM yacht to be almost half the weight of a boat manufactured the traditional way, the main reason being the ratio of glass to resin and the engineered foam cores. The next step is to laminate all of the layers together and remove excess resin. To do this, they vacuum bag the entire structure. They first lay down a breather material designed to help distribute the vacuum pressure of 1 ton per square inch evenly over the entire surface. During this process, the breather material also soaks up excess resin. The next step is to apply a strip of pliable adhesive to the outer edges of the mold. This will then adhere to and create an airtight seal with the plastic bag cover. Then a worker strategically positions several connectors, cuts out a small hole, and seals the connection point to the plastic. Next is to hook up one of several vacuum hoses and begin the process of removing all the air. Being under a vacuum, any air bubbles are removed. The components are laminated together under vacuum pressure, and excess resin is drawn into the breather material. For the next 30 to 40 minutes, the team works to ensure that the plastic is smooth and fitted into all areas, with no bridging, as they call it, areas where the plastic is not flush with the structure. After vacuum bagging, the next step is post-curing the deck or hull. This is done by building an enclosure over the deck or hull and heating it for 8 to 12 hours. During this curing process, they monitor several key points with thermocouplers. As you can see here, each mold is pre-wired with up to 14 different sensors to allow for precise temperature measuring during post-cure. This is all controlled and monitored from this laptop station. The end result is an incredibly strong, durable, air-free deck or hull that has been laminated into one solid structure. Looking here at the edge of the deck, you can see how the structure has been compressed. These cutouts clearly demonstrate the different layers of material as well as the result of the process, forming a solid unit, which is surprisingly lightweight. Taking a look inside the finished hull, it is difficult to show on video just how sturdy and rugged the entire structure is. The stringer system has become one unitized part of the hull along with these internal bulkheads. This entire yacht, with the exception of a few hatch covers and the hardtop supports, is solid epoxy resin and glass. That's our look at the lamination process for an MJM yacht here at the Boston Boat Works. For BoatTest.com, I'm Christopher Hughes.